Hi, welcome to my channel, JaberTime. Today I'm going to talk about mainly the radical functions. I have a list of keywords, as you could see, square root functions, cube root functions, inverse relations, inverse functions, horizontal line test, vertical line test, domain and range, and domain restrictions, and the line of symmetry y equals x. Let's get into it. Determine the inverse of the power function y equal x to the second. And to get started, algebraically through steps, we're gonna switch x and y. We'll go back. Hi, welcome to my channel, JaberTime. Today I'm gonna talk about radical functions, and I have a list of keywords, as you could see, and two graphs that shows reflections and inverse functions and relations. Let's get into it. Determine the inverse of the power function f of x equals x to the second, or sometimes we write it as y equals x to the second. To get started in steps algebraically, we're going to do the following steps. Step number 1, switch x and y. So if I have y equals x to the second, switching x and y will be written as x equals y to the second. Now the reason why I switch x and y, for example, if you have it as an ordered pair x and y, and you write it as y and x, you're actually switching inputs and outputs. And if 5 takes you to 25 under this square function, if you want to go back from 25 back to 5, that's called inverse. So by switching input and output, or x and y, we are actually doing the inverse. Now the new y, we need to solve for it. Applying the square root to both sides, I get y equals plus minus square root of x. For each value of x greater than 0, there is both a positive and a negative value of y. Anything you plug in right here with a plus minus is going to give you two answers. The graph is going to support that in just a second. So we have y equals plus minus square root of x. Here's the graph with some comments about the graph. This is y equals x to the second. This is y equal plus minus square root of x. The graph of the power function y equals x to the second and the graph of its inverse y equals plus minus square root of x are symmetric about the line y equals x. You see the line y equals x? If you have this as a paper and you want to fold the paper along y equals x, you could see that this point gets reflected here, this point gets reflected here, and so on. Even the horizontal line, what we call it horizontal line test, will be actually reflected right here and will be the vertical line test. The line y equals x is a line of reflection or a line of symmetry. So graphically, when you want to find the inverse, we take the reflection about y equals x. In steps, that's what we do. We switch x and y, and we solve for y. Later on, we're going to discuss that this graph does not pass the horizontal line test, which means it's not one-to-one and it's not invertible. And if you do invert or find the inverse of it, this becomes a relation and it's not a function because it doesn't pass the vertical line test. So we have here negative 2 takes me to 4 and 2 takes me to 4, and the horizontal line test shows you that they both share the same output. So the graph does not pass the horizontal line test. But if you do the reflection about y equals x, you're going to end up with a plus square root, the principal, and the minus square root. In short, we write the whole thing as plus minus square root of x. Notice that negative 2, 4 and 2, 4 are here as 4, negative 2 and 4, 2. Vertical line test tells me that this is not a function. As you can see, the 4 as an input has two different outputs. So it fails the vertical line test, which means it's not a function. The function f of x equals x to the second and the inverse of f of x, which is written as y equal, so it's not written as an inverse function. We're calling it inverse, but we're not calling it inverse function because it's not a function. Let's find the domain and range of each of them. The domain right here, as you could see, this is increasing all the way, and this is increasing or going up all the way. So there is no limit on left and right. It goes from negative infinity to infinity. The range, which is the y values, starts from here and goes all the way up. So it goes from 0 to infinity. But notice the range right here, same concept, going all the way up and goes all the way down. So it's from negative infinity to infinity. Let's go back to the domain right here, which I mentioned from this level all the way up from 0 to infinity. And the domain for this graph is from this level 0 all the way to positive infinity. And if you notice right here, the domain of the function is the range of the inverse, and the range of the function is the domain of the inverse. I know I'm using the same color here, but this is x in this graph and this is y in this graph. Just to be aware of that. So this right here is a plus minus square root of x. Notice that the inverse of the function f of x equals x to the second is not written with the notation f inverse of x. This right here is not written in this format. Why? Because the inverse of the function f of x equals x to the second, this right here, is not a function. The inverse notation is used only when the inverse is a function. Domain restrictions. To solve the problem, we're gonna deal with domain restriction. So if we don't take the whole parabola and we take only the right side, including 0, this is called y equals x to the second with x being greater than or equal to 0, restricted domain. The reflection of this about y equals x will be this graph right here, which is known to be the principal square root of x. So we have the domain restriction. We have the inverse function. This time we are calling it inverse function. Not just inverse, it's inverse function. And we're using the notation that we just mentioned, f inverse of x. Same thing, I'm writing it this way so you could notice that the domain of the function is the range of the inverse, and so on and so on. Well, this one right here as a domain goes from 0 all the way to infinity, and range goes from 0 all the way to infinity. And the range right here goes from 0 all the way to infinity. Different colors, but we are on the first quadrant. They kind of like go all the way up, goes all the way right, so there is no restrictions about the end starting from 0. Later on we're going to have an example that starts at 4 or negative 4 or negative 2, so we'll see the difference. But one more time, the domain of the function is the inverse, is the range of the inverse, and the range of the function is the domain of the inverse, because our inputs becomes our outputs and our outputs becomes our inputs. Here's the two graphs. combined in one graph. This is y equals x to the second with the restricted domain. This is y equal square root of x that goes as a reflection about y equals x. Determine the inverse of f of x equals x to the second minus 4. This is a parabola that shifted down 4 units. To do it in steps, we're going to switch x and y. So we have x becomes our y and y becomes our x. So we write it x equals y to the second minus 4. Then we solve for y. To solve for y, I'm going to add 4 to both sides. This cancels. Y to the second becomes by itself on the right. On the left, I have x plus 4. Take the square root of both sides. I have y equals plus minus square root of x plus 4. Now to graph this function right here, it's a parabola that is shifted down 4 units. We could see that it doesn't pass the horizontal line test, which means it's not a one-to-one function, which means it's not invertible. You could see that 2 and negative 2, they both go to 0. 2 takes you to 0, negative 2 takes you to 0. Whenever you have the same output for 2 different inputs, it's called not one-to-one. Let's see what this will cause if you reflected about y equals x. So if you reflected about y equals x, this is what you end up with. This point will be reflected on the negative x-axis as negative 4, 0. Now this is what we have here, which is plus minus square root of x plus 4. It doesn't pass. See the 2 dots right here? The vertical line test. So it's not a function. You could see 0 is going to 2 and 0 is going to negative 2. 0 has 2 different outputs, or the vertical line test shows that at the same level of x, I do have 2 different outputs, one up and one down. And that's where it's coming from, plus minus. We're going to restrict the domain and end up with a solution. Before I move on, if you want to see this as 2 graphs, which is 2 functions, we're going to see it this way: the plus square root of x plus 4, which is like square root of x shifted to the left 4 units, and the bottom one will be the minus square root of x plus 4. Now both graphs on the same grid, you could see the reflection. This point is reflected right here. This point is on the line of reflection, stays right there. And let's see, this point right here is reflected right here, and so on. If you fold the paper along y equals x, you could see the whole thing kind of like overlaps and matches. Let's talk about the domain and range. Again, just to enforce that the domain of the function is the range of the inverse, and the range of the function is the domain of the inverse. Looking at the red part right here, the parabola that is going all the way up, shifted down to 4 units, the domain will be all real numbers, and we write it from all the way to negative infinity to all the way to positive infinity. Looking at the range of the inverse, it goes from negative infinity, which is y values, all the way to positive infinity. Same answer. Let's look at the range of the x to the second minus 4. Starts from here, which is y values, goes all the way up. So we're going to go from negative 4, including negative 4, all the way up to infinity. That should be the same. Let's take a look. Here's the graph, which is plus minus square root of x plus 4. We need the domain. The domain is x. Starts right here and goes all the way to the right. So it's going to be the same thing. From -4 all the way to infinity, including -4. Let's restrict the domain and find the inverse. This time we're going to call it inverse function. This is just an inverse, and it's not a function. Vertical line test for the square root plus minus, you could see that it does not pass a vertical line test. To restrict the domain of the graph in red, we're just going to take the right hand side and drop the left hand side, so we could have the horizontal line valid or passes through the graph without any issues. Here's y equals x to the second minus 4, only the right portion, x greater than or equal to 0. The reflection of this about y equals x will be this graph. This point is right here, this point is on the line of reflection, stays right there, this point right here is reflected right here, and so on. In other words, we're taking the upper portion, we're not taking the lower portion. And moving on, I have x to the second minus 4. We're going to restrict the domain to be x greater than or equal to 0, as you could see. Finding the domain or stating the domain of x to the second minus 4 with the restricted domain is just going to be from 0 to infinity. This right here is going to be the same. The range of the inverse is the same as the domain of the function. Let's take a look. Range is y. For this graph right here, range starts from here and goes all the way up. So it's from 0 all the way up to infinity. Now, the range for the function in red will be the y values, which is from -4 all the way up, from -4 to infinity, including -4. That should be the same. Let's look at the domain of the inverse. The domain is x values from -4 all the way to the right. Notice right here we called it f inverse because it is a function. In the previous slide it was just y equal. Okay, let's take another example. Determine the inverse of the function f of x equals x cubed. The cube root function is the inverse of the power function f of x equals x cubed and can be written as f inverse of x equals the cubic root of x. That's how we write it down. To save you some time, I have both graphs at the same time for you. This is the cube function, x cubed, and this is the cubic root of x. As you could see, if you have put them together, that's a reflection of this graph about y equals x. For example, 2, 8, because 2 to the third is 8. Here, it's 8, 2, because the cubic root of 8 is 2. This time it's called inverse because it is a function, inverse function. Vertical line test passes. Horizontal line test here passes through. So it's invertible and it's 1-to-1. Let's find the domain range, and you could see that this will be here and this will be here, will match. Domain is all real numbers. Range here will be also all real numbers. Range for this function is going to be all the way up, all the way down, still all real numbers. Here, the domain will be all the way left, all the way right, all real numbers. In this function, 2 will take me to 8. In this function, 8 will take me back to 2, and it's called inverse function. Having both on the same grid, you could see the reflection. This goes down. Once it crosses, it's the same point on the cubic root, and it curves back, goes through the origin, and it curves back down. Okay? Determine the inverse function of the function x to the second plus 2. You could see this is a parabola that shifted up 2 units. To find the inverse in steps, we're going to do the same thing like before. We're going to switch x and y. So y equals x to the second plus 2 becomes x equals y to the second plus 2. We're going to subtract 2 from both sides and solve for y. So let's subtract 2 from both sides. That will give me x minus 2 on the left and y to the second on the right side. We're going to apply the square root. Don't forget the plus minus. So I have plus minus square root of x minus 2. Graph this. That's a shift to the right side, 2 units of positive square root of x minus 2 and negative square root of x minus 2. You see the horizontal line right here? That says this function is not invertible and it's not one-to-one. This right here, we have a vertical line test that says this graph is not a function. It's an inverse relation, but it's not a function. Now, restricting the domain, we're gonna take one side only, and this will end up this side only. Let's take a look. F of x equals x to the second plus 2 such that x is greater than or equal to 0. Reflecting this about y equals x, you could see the reflection. That will be f inverse of x. It's a function, as you could see. It's an inverse function because it passes through the vertical line test. The function right here with the restricted domain, this is an inverse function. There is no plus minus, just a regular positive principal, square root. One more time to practice, we're going to see that this will be here and this will be here and so on. The domain of this will be x values, which is from 0 all the way to infinity. The range for this will be from 0 all the way to infinity. Let's look at the range of the original function, which is y values from 2 all the way to infinity. Let's look at the domain of the inverse. The domain is x values from 2 all the way to infinity. Now, let's do it the other way around, which means if we have this and you want to find the inverse of it, it's a little bit tricky, but I saved it for the end because now we have enough information about the inverse and the restricted domain and so on. Let's take a look. Find the inverse function of f of x equals square root of x minus 2. I have the graph, you know it. We're gonna find the inverse. Well, just pay attention to this. Y equals square root of x minus 2 has a range, y values, from 0 all the way up. When you find the inverse, that will be your domain. Remember how many times I said like your range becomes your domain and your domain becomes your range? If this is my function and this is my range, once I find the inverse, I need to think that this is going to be my domain. From 0 up, that's going to be my domain. Let's take a look. Switch x and y. We're going to switch x and y. So we're going to write it as x equal square root of y minus 2. And we're going to square both sides. Now we have x squared equals y minus 2. We're going to add 2 to both sides. This cancels and we'll have y by itself equals x squared plus 2. Or if you rearrange, having y on the left, you'll have y equals x to the second plus 2. Now this is an inverse function, so we're going to call it f inverse. But if you graph this without paying attention to the domain, this is a parabola that opens up, shifted up 2 units, that has both sides, right and left. Be careful. The domain should be only greater than or equal to 0. Comes from here. The range of the function is the domain of the inverse. If this is from 0 to infinity, the domain should be from 0 to infinity. So we have f inverse of x equals x to the second plus 2, such that x should be greater than or equal to 0. Let me show you the graph. This is my function. This is the reflection. The range right here is from 0 to infinity. The domain here is from 0 to infinity. We have the function, we have the inverse function, and that's an inverse function. Domain and range, domain and range. The domain here is from 2 to infinity, and the range here is from 2 to infinity. The range here, y values, from 0 to infinity, and the domain for this will be x values from 0 to infinity. To summarize this, I have the following. The range for this graph was greater than or equal to 0. It will be my domain for the inverse function. And as you could see it right here, the range was from 0 to infinity. The domain was from 0 to infinity. So if you don't pay attention to this, you're going to say x squared plus 2. We're not taking the square root and writing plus minus. It's the other way around. When we have this and you square both sides, we don't see anything about plus minus or domain restrictions or anything. So if we don't think about this and taking it with us, that's a parabola that has both sides, right and left, which is not true. The reflection of this should be one piece only, not the whole parabola. And that should be it for this video. It's about half an hour. I think that's good enough for this radical functions, domain range, and domain restrictions to end up with an inverse function, not just an inverse. Thank you for watching, and I'll see you in the next one. Thank you. Thank you for watching. Don't forget to hit the like button, subscribe to see some more, and I'll see you in the next one.